next.
Yeah, we're going to do a live demo, and I'm already predicting that it might become very difficult to read, but I'll try and repeat and talk about everything that might show up. Very quickly, I'm Rogier Fischer, founder and CEO of Hadrian, which is an offensive security emulation company. We build AI models to pretend to be the threat actor. We do that at scale. We work primarily for larger enterprise, mostly banks and large industries. My background is actually ethical hacking. I've done that since I was about 12 years old. It's always fun, and I feel like if you get pulled into the ethical hacking game, you probably never get pulled out again. And at least that's how it was for me. I stayed doing that well until now, and it's now more than half of my life. In 2012, I was one of the co-founders of cryptocurrency exchange, which on its own was quite a large security project. As you can imagine, we were a big honeypot of crypto assets. In 2018, the company was acquired, and in 2020, I left. 2021, I started Hadrian together with a good friend of mine who is also an ethical hacker. So today's talk, I want to give you just a quick rundown of what we're building, but also give you some real-life examples of adopting AI and specifically large language model in exploit development, and also how to deploy that at a really, really large scale. But before going into that, I just wanted to give you a bit of context why we think it's extremely relevant that we started the company, although obviously that is my personal opinion. So I don't necessarily like Gartner as a company. It always boxes every company and every tool in a specific category, even though often it might not be a perfect fit. But this is one of the quotes that I tend to really like. With the emergence of AI, you also see a democratization of offensive security in the space that, in the sense that it's become really easy to attack, which means that it also becomes more relevant to be aware of what type of attacks can come to you much faster than before. Right? Exploitation from new vulnerability to actual exploit in the wild, the time has just significantly decreased. And that's also why it's important to increase the amount of testing that you're doing. Attack surfaces are basically the fingerprint, the footprint of companies have expanded quite significantly. And obviously, especially in larger enterprises, you see that they have often no clue what they're actually looking at. So I can give you a long list of examples of how you get into a company, but I always give one of my favorite examples, which was a couple of years ago, when me and my co-founder broke into the headquarters of Spotify through an internet-exposed clock that was open on a port where, I really don't know why a clock necessarily needs to be internet exposed and on a separate IP and also open to the internet. But B, obviously, whoever built the clock had no idea and was not planning for it to become an entry point into your network. And that's really something that you see now more and more often. There's a lot of OT, IoT that is just not visible for the security managers. There's actually been other tools in the market that have tried to solve that problem. We call that attack surface management. Most famous are Expanse, RiskIQ, both are acquired by large cloud companies. But you also see a little bit of an evolving category here. And I know that it's difficult to read, so I'll try and read it out. But basically what you started out was asset discovery. Like I said, you find the clock, you find IPs. With a bit of contextualization, knowing what you're looking at. It became, the addition to it was active testing. So people, apart from knowing that you have something, started running security tests, vulnerability scans at it, and based on the context, started scoring risks for it. And you're seeing now that it's combined with fully automated pen tests, meaning you can combine multiple issues into full-fledged attack chains to actually get to crown jewels or to a specific piece of data that you'd like. So this is actually the talk about today. It's applying AI, and specifically, obviously, generative AI in this case, to offensive security, and in that sense, the race against threat actors. Because that is our main point, right? It's really about speed. Speed of being able to test for new 0 days, but also speed of knowing when a new 0 day has happened and detecting it. So then looking at using AI to develop exploits, it's really funny, you can't read it. It starts with training data. A general LLM is actually really, really good at it already. So you don't have to massively change it, especially the newer LLMs are quite good at building exploits based on a lot of context. But you want to have some form of supervised learning so you can get quite specific and also repeatable in that sense. So then, of course, you train the data. Interesting fact here is that it's actually more difficult to train a model to recognize when something was successfully exploited than to actually build the exploit. Once you have the exploit, you want to verify that it's relatively safe to use, with safe being between brackets, because you don't, we run these tests on production environments at scale. We don't want to bring down our customers and be the threat actors themselves. And then, like I said, you need to verify the safety, you need to verify the results of it running. The vast majority of exploits that you run against an attack surface result in a true negative, right? We were not able to use the exploit. That's also why you see that I think the CVE system is really bad, because for the vast majority of categories, CVEs are just side cases, edge cases that can only be exploited under very specific circumstances, which means that they're very bad if you want to make big lists of priorities. Well, again, verification here is quite important. Just for context, we are running somewhere between 10 and 20 million exploits on a daily basis today, and you probably find around 500 positive results on that. So it's a really very small percentage of exploits that are actually executed successfully. So how do you train it? Well, first and foremost, like I said, LLMs are actually quite good. If I compare Cloud 3.7, which was our latest, I mean, obviously now there's Cloud 4, but Cloud 3.7, if you compare it against in its raw capabilities of being a dust compared to like a Tenable Qualys, it tends to outcompete already, which means that those companies really also going to have to reinvent themselves. But like I said, on top of that, you need to add context, especially if you want to chain vulnerabilities together to get a more interesting attack path, get to an actual prioritized risk. This is where you add your own training data. So what we do ourselves is we train our models with reinforcement learning on bug bounties. I'd say that that's the most common methodology, because there's a lot of companies out there that you're allowed to attack, and you can track the data. And when you have a hit, you can store that, understand why it was a hit, and at that point, train your model around it. But there's actually a lot of other sources that you can use as well. Our first version, about 3.5 years ago when we started, was based on a book, which was very simple. A book that was laying out how to do very simple dust type capabilities, and you just read the book and it created the exploits on its own. So one thing that we already realized quite soon in this development is that we tend for larger enterprises to have really large attack surface and usually tens of thousands of applications, which means that scalability is one of the main and key challenges. You can't create one size fits all model that just fixes all your problems and is able to exploit every vulnerability and is able to everything. What you'll see is that your model becomes too slow and it starts to hallucinate and becomes inaccurate. So instead, you build smaller models that are very targeted and have one specific specialty, and you also train those models specific on those types of exploits. This makes that the model operates much faster, and also, therefore, it's far more scalable to deploy. So once you develop the exploit, like I said, you want to verify that it's safe to use. And again, this is actually the third machine learning model that comes into play with running a single attack, which is the exploit creation, the safety check, and the impact analysis. All three of them you train with different data, but you have a specific type of safety data where you say, okay, these are the types of exploits that are safe to run. And you verify that in your large language models, actually. This is probably the easiest one to build of the three. So just a very easy example. An SQL injection would be going through this loop. You find an endpoint in a discovery scenario. You ask the model, hey, I want you to test for SQL injections. It creates multiple different types of SQL injections that it thinks can be relevant in this scenario. Might be edge cases. It might start to see, for example, that it triggers an error and then it adjusts the payload a little bit so that the error gets fixed and the SQL injection is executed successfully. It goes into that safety check. Very obvious one, you should not drop a table with users, but you can make the system sleep for a bit. And then you check and verify based on the response. And in a blind SQL injection, for example, it can be time-based, and trying to understand, hey, was the exploit executed successfully? And this then feeds back into itself when it was unsuccessful. So as I already briefly mentioned, if you want to truly accomplish a scalable system here, you're going to have to split up your capabilities in specific, well, I don't like the word agents, but in the end, that's how the AI communities decided to call them. And you basically make them specialty in specific types of exploitation. In our case, we actually have agents not only specialized in attacking, because the vast majority of work and data that we track, it's about building context. So even before you start building an attack, you want to understand what are you attacking and does it make sense. Just to give you a very simple example, in the US, we have a very large hospital chain that we're working for, and at some point they had an IP exposed with printer management software, which clearly was identifiable as printer management software. But there was also a registration page. And you could register an account, and at that point you were logged into the printer administration page and you could see everything was being printed. So without even running a specific exploit or an attack, the AI model is relatively easy able to determine that that's a problem and should be resolved. So even before you are actually running exploits, you can already start to find ways to exploit the system. Another example was we worked for a very large air carrier, and they were exposing some server logs to the internet, and the vast majority of cases, somebody exposing some logs is not a huge problem, it's more a hygiene issue. But in this case, there were track and trace codes and postcodes in those server logs. And a pen tester is very easy. It's very easy to assess, hey, okay, so I can probably do something with that. A large language model also. They can immediately understand, okay, with the track and trace code and postcode, I can log into the system and change the location of the package or grab some personal data. A vulnerability scanner, the old school way basically, is obviously not able to make those decisions. And this is really where that automation comes into play. So just to see how the flow would look, right? You start with an application. It doesn't have to be a web application, but in this case, it's a web application. You get an agent that does a lot of contextualization, press buttons, browse, does everything a normal user could be doing as well. And then there is what we call orchestration layer that decides based on the context what is now relevant to start doing. So this means that also you can be very specific in the types of the tests that you're running for. Right? If you already assess that the application is built on a C# framework, then you should be able to craft your exploits also in the direction that it will be exploitable in a C# environment. And the same goes for Java applications, etc. So again, it's difficult to read, but this is basically how we set up the system. It's actually very difficult to read. I'll try to talk you through it again. So this is what we call the orchestrator AI, a very original name. it basically orchestrates between modules. So we currently have around 300 individual modules. Those are not all AI, right? They can be just a very simple port scanner or some other application that just does something very binary. But there's a lot of different modules that are obviously almost entirely a machine learning trained function. And those modules can be categorized in 4 different steps. There's discovery, which helps you basically define the scope of how you can attack a company. There's contextualization, which tells you what type of attacks might become relevant, but also what type of data is being transacted. But it can go quite far, right? So one of the things that we do is we train an AI model based on web archive data to understand how old something is. Because based on how old something looks or feels, you know exactly what type of attacks might be relevant or not relevant anymore. You can imagine that the React environment, front-end page, is exploitable and attackable in a very different way than an old school post-based web page. So context is a really big chunk of that, and then you get to the risk finding, and then you get to the prioritization. So the risk finding is, like I said before, those are all those individual specialized modules. Sometimes there's even a module specifically for just one type of attack path that has become very common. Log4j would be a prime example where you want to build a specific module for, especially because it's still so common. In the end, you then prioritize based on CVSS score first, but then on that business context that you've assessed before, and a bunch of other data sources and threat intelligence. So just to give you an example, we have on the website a couple of examples, but I like this one because it's quite simple. We work for a large company in Europe called Leroy Merlin. It's a DIY chain, mostly in Southern Europe, but they also have stores in Ukraine and Russia, which meant that they had quite a sizable exposure in recent years. So in this case, we found exposed assets in Italy, and that was running accounting software. And that is something that you can detect relatively easy again with a large language model. We also detected it was a Java application. So immediately an AI model starts looking for potential sensitive file paths in Java applications. And it finds a heap dump with some data in it. So that is already something that usually a vulnerability scanner would potentially miss, because you cannot brute force for every single sensitive file path out there, but you can do that once you get actually quite some decent context on the company and you know exactly what type of things you are looking for. So the heap dump was opened, we find some credentials in there, in this case credentials to their Google Cloud. And from that moment onward, we were able to use those credentials, those API keys and SSH keys, to enter the Google Cloud and prioritize this to a critical issue. And in that way, in a completely autonomous manner, actually in also just a couple minutes, you start with a brand and you end with Google Cloud Access. And that's exactly the type of attack paths that we try to automate. This is actually one of the simpler ones. Before we go to the demo, are there any questions on this? We have one.
How do you, I guess, sandbox your own? I guess if you were to train a sufficiently intelligent AI that is around companies, or perform things which could.
So that's where that training, that counter model around safety comes into play. So you always have first a model that creates the exploit, and then secondly a model that is specifically trained to stop it if it thinks it might be something that is destructive in nature. So first and foremost, already during the training, and also by the way during the execution, it's you give it very clear guardrails, right? So it should not go out of scope, quite frankly, because that's just not what it's designed to do. And those things are actually not too difficult. You can fairly easily give it guardrails. But specifically around exploitation, especially if exploits become very complicated, right? I think proxy shell would be a good example, where you chain multiple exploits together. And it's actually very well documented how to chain those exploits together. So at that point also the AI is very capable of doing that. Then you have to really have it like a counterpart where you're saying, hey, is this actually safe to use? That's the main way of, hope that answers the question.
Yeah. Just check, from the scope perspective, you're focusing here on like web applications. Are you able to do connect infrastructure as well? And also on the web application front, websites, okay, it's easy to go around and discover and explore, but APIs tend to get stuck if you don't have like an API Swagger file. Is your tool able to do anything that doesn't recognize the API?
So one of the things that, for example, an API works is because so let's say the API is powering a React app, then by just tracking all the requests that are happening by clicking around, you can build a pretty accurate picture of the API. And you will never get a full picture, and you will have to do some parameter brute forcing as well. It's a little bit where this platform that we're building is never going to automate everything. What it needs to automate is the bare minimum of what we believe threat actors are also able to automate. Right? If you're going to send a manual threat actor against one specific asset that has one very specific edge case need scenario, it's unlikely that an automated system like this can discover it. But the vast majority of attacks are automated in fashion anyway. So then you want to be able to compare against that. And for your question on what type of applications, so in the essence, I always say, look, it's internet defined. Right? If it's internet exposed, then we will try and see and exploit it, which means that the vast majority of cases it's a web application, but very often it is other types of protocols, and even the DNS layer is probably one of the most common, right? Where you also will find a lot of problems.
Why don't you start on the legality side of things? So you guys did it, the exploitation, did the monolithic exploitation. It's a bit of a gray area.
So it's not particularly legal. So it's obviously very illegal when you do it without permission. So one of the main problems that we have is our customers making mistakes with their own scope. Right? They add IPs or domains that don't belong to them, or they add what they believe are their IPs, but they're actually dynamic cloud IPs, and after 10 minutes it rotates to something else. So we have to build a lot of tools to recognize that. Like one of the things that we do is we built an open source, actually you can find it, a sonic scanner basically, to track where all the dynamic IPs are pointing to. So every 10 minutes we try and allocate where the 250 million cloud IPs of the 3 large cloud providers are pointing to, and whether it has changed with our customer. Because we can't have a mid-exploit suddenly we start attacking something else, right? That's risky.
You mentioned you went to 10 million plus attacks. Vectors. So is that how big the database is? It's got that many patterns stored, or
So a lot of the patterns are repeatable, right? So it's not unique patterns that we see, but almost every attack will have unique elements, in the sense that it will try so based on the context it has assessed, it will try some unique methodology. But you can categorize them in fairly common vulnerability patterns.
Because the population computation of that is about 10 million. So they are a much smaller group.
So we run. So I'll actually just give you an example as well. But we have around 250 companies that work with us worldwide. Around 100 larger enterprises that have at least 10,000 IPs and domains. So those all are on the receiving end of our attack emulations. Some attacks you want to run every day, not a lot. But some attacks, once you've disproven that it's not possible, next time you want to run them is 2 months from now. There are scenarios where you want to do them more responsive, right? So, for example, the actual desk capabilities, we do it based on tracking change in web applications, seeing how, so look, this application looks like it has changed, let's rerun the test, which comes from an event-driven network. Like this whole system that you're seeing, the whole architecture is built on a Knative structure, which means that all these modules can trigger each other, but it means also that when I trigger a module again somewhere in the middle, it propagates to the network and just reruns everything according to what I think it should be doing.
And you can regulate with frameworks like EU or here in the UK, and they've got a little bit of a way to go to catch up to what's happening here, to include things like this in there. Also came from regulatory point of view.
Legal and compliance questions. I didn't expect them to get them today. So I think rightfully so, most compliance frameworks are vague, and that's probably it's probably best because you want to actually leave the security up to the professionals, and you can't update regulatory frameworks every single week. So I actually kind of like the fact that some of these frameworks are very broadly defined and basically just say you should monitor your risk to the market standard or whatever, right? Because once the market standard changes of what you should be doing to maintain your risk appetite, then that also means that companies will have to catch up. Say NIS2 is probably a really good development though, primarily because of the board level responsibility that comes into play.
There are a lot of cloud scanners are there, for like suppose we have all deployment
Yeah.
for how your security. So how is this tool is different from that one? Scans the cloud and says like how your how the configuration are. Right? Doesn't give enough security. Like if I have implemented very good idea.
Well, because you're gonna, I mean, not necessarily you perhaps, but companies tend to have a lot of things that are not necessarily running on the cloud. And also, even if you have it on the cloud, I mean, we obviously build standard cloud integrations. I mean, we're not competing with Wiz, right? I love Wiz as a tool. We're customers ourselves with Hadrian as well, but it's a different product. We compete primarily with the black box testing capabilities of well, either manual pen tests or vulnerability scanners, if that makes sense.
I was wondering about the distinctions between the more conventional automated tooling methods and the specific AI trained ones, i.e., could you give examples of what those specific AI trained endpoints are and why they're different from just, let's say, LLM as a reasoning orchestrator with a bunch of tools that you mentioned?
So I think it's largely that, right? It's because the LLMs are extremely good at building that context, which I think is the main advantage that you have, because that's what the human brings into a pen test as well. Logical understanding of what's happening. So then there's very specific problems where you want to train your own LLM because it's just better at doing some things like, I mean, simple things like image recognition, to allocate assets, or like I said, the age prediction, where it's like just some extra context, which it's a very small model, but it just gives you some extra context to work with. But the vast majority of context building happens with relatively easy LLMs. Orchestration of that is probably not as easy at scale, but yeah, if you do it for a very small environment, you can probably build something yourself.
There's one quick one. With your testing around using different, obviously you test using many different models, is that the base model kind of built off of? Have you found larger models to work better or smaller models to work better for those specific?
So we tend to work with as small as possible models to be able to reach the scale that we need. Because the bigger the model, the more costly, but also just time constraints become an issue. And then you train it for a specific purpose and then you run it in parallel. But yeah, I mean, even the larger LLMs nowadays are not that big anymore, right? So you can relatively use, so for me, that's good enough, right? The main thing is that There are other companies, by the way, and I'm very impressed with, for example, Crossbow. I'm not sure if you guys heard of it. It's a Sequoia-backed company are building, but they're basically trying to put this whole architecture into a single AI model, and that will work. It's just that it will be slow and very costly to run. And if you're going to do that on tens of thousands of IPs in parallel and domains, then it will be difficult. So what I predict what will happen is that in the end, companies will kind of have to switch to something like this just for efficiency's sake. But then you do have a single module that might be like your AI squared pen tester, whatever, that you will use on very specific assets where you deem it necessary. And that could be like an Expo could also become the next open source model, because there's a lot of open source models now available doing exactly this as well.
I know pen testers aren't deterministic, they have good days and bad days, but with your model, how do you actually kind of test to make sure you're not regressing with your capabilities to make sure that this is as repeatable as possible?
It's a good question. It's difficult because once you find something, you report it to a company, they tend to fix it, so you can't go back and train it again on the same scenarios. And there's only very limited of predefined test cases that you train it on, and it's actually quite boring. That's usually quite useless data. So we don't really have a methodology right now to track regression in the quality of the testing. Should look into it. That's not something
You mentioned earlier that you analyze the pattern to see if it's safe enough to run or not.
Yes.
But don't you really want to run something to check that it exists enough? How do you strike a balance between safe and then would you not run that in a sandbox so that even if it's not safe, it's still contained in the sandbox? So maybe I can understand the.
So the thing is, we run our tool black box on internet-facing assets, right? So company gives us their brand, and we say, okay, based on that brand, we're going to find where you are, who you are, and we're going to attack you.
Right.
So we don't have the luxury of being able to test things in a sandbox. We really take a seat as we are the threat actor, and we are equivalent from that perspective. We're not giving any additional information that could help us, but it also means that the information that we do find is something that others can find autonomously as well. So of course, ideally you would run everything in a sandbox, but you can't, which means that the balance that we strike between safety, and safety we hear implying risk of disruption versus proving that an exploit can be done, we will always pick safety. In the platform, actually, I've removed a lot of the screenshots from the platform because this was not supposed to be a sales talk. But we distinguish that where we say, look, there's a verified exposure and our potential exposures, where we identify that we want to try something, but we just don't, right? And that another very common example is like endpoints that are vulnerable for a denial service. Right? You see, oh, well, this is a common attack pattern where I can bring down the machine by doing X, Y, and Z. But yeah, of course, I'm not going to actually try it.
So you're not trying to bring them down, you're just trying to kill them. That is a problem.
We try to do the bare minimum to verify with 100% certainty that the exploitability is there.
And do you report the ones that you think are not safe to do but are possible?
Yes. So that would then be a potential exposure. So basically in the platform, we have the verified exposures, which are like they come out of the system and it's like, okay, here's a POC, here's how we did it, this is the outcome. And for us to call something critical, it has to be a data breach or a ransomware. Otherwise it can only be like a medium. Highs are in that sense also fairly highly tolerated, which means that you can have a CVSS score of 9.8, but if it doesn't lead to a data breach, then it's still medium. It's in that sense quite strict, but on the other side, next to the verified exposures, you have potential exposures. Potential exposures are also vulnerabilities that just don't lead to any real problem right now, right? This is what all your security scorecard and BitSight reports will tell you, right? Oh, you have all these bullshit problems, but as a hacker, I will not be able to use them unless I can combine them with 5 other things. right? Cross-site scripting together with some HTTP misconfigurations and some cookies that are acting weirdly. Okay, now I can potentially try an account takeover. But standalone, these issues are probably insignificant. So they were then also classified as potential exposures.
Your context understanding what's going files. Is it going through and reading these files which are publicly available, what we get access to the information?
Yeah, so JavaScript files, sheets, etc. Yeah.
Is there any form of protection you can have on, let's say, which is convention faults or something like that?
Yes. Yes. So we obviously assume that I would take one step back. Before I started this company, there was a really large competitor that I knew how they were working, and I also knew they were running an old version of Chromium, and they were taking the screenshots. So I knew that once they would visit my website, I had complete control over their machine. So it's exactly the type of things that you would need to defend yourself against because you're parsing a lot of data. It's like it's specific by this specific use case is relatively easy to serialize, but I mean there are more prominent edge cases that I'm more worried about. If there's no other questions, then what I'm just going to do is I'm going to run, and this is the beauty of it being such a small model. Is that you can run it locally. So this is also, in that sense, a very simple model that finds a cross-site scripting in a very standard OWASP demo environment. And even if I make it really big, you can't really see anything. But just what it starts to do is it starts up a Chromium environment, goes to that web page, finds all other files that are associated with it, passes them, starts finding also the variables that are defined there, parameters that are used there, everything that can be used to at some point craft a hypothetical attack path. So in this case, it also found input parameters, email, password, and search on the page. It's now analyzing the JavaScript files to see if there's any logic there it might be able to exploit. And in essence, it first finds all these variables that are defined somewhere, tries to understand how, get some additional context from the headers and technologies that are running on the page, which again can become relevant in a later attack stage. So these are already multiple small models communicating with each other. Based on this information, it says, hey, I have these 3 input fields, text, email, password, that I want to start trying an exploit for. And in this case, it sees that input is reflected somewhere on the page. And based on that reflection, it's built a hypothesis that this might be a place where you can input some form of cross-site scripting. In this case, it crafts 6-7 different cross-site scripting attacks. All of them have passed the safety check because cross-site scripting tend to not to be very dangerous, and then starts running those attacks as well and analyzes the response. In this case, 4 out of the 6 attacks failed. For whatever reason, the others were not exploitable. In this case, because the type of cross-site scripting required, there was a certain type of WAF application in front of it that required an exploit that circumvented that. And in the end, it draws the conclusion and say, hey, we found cross-site scripting exposed. So this is obviously something fairly easy that a Dust can also do. I just wanted to give you a bit of an idea of how you can connect these multiple dots together. And then I can also just quickly run it on the environment. So in this case, it was the search bar that was vulnerable. how much time do I have left? 5 minutes. Just wanted to give you a quick last example. One of my big hobbies is still bug hunting, and especially finding 0 days, but also when new 0 days come out, tends to get me excited. So when I'd say probably now it's already like 6 months ago, there was this huge hype around the new bug in Linux coming out. Turns out it was very, very boring. But it was dropped on a Friday, 5 p.m. because one of the developers pushed it to their GitHub and forgot that at that point he pushed the fix so everyone could see how it worked. That was the CUPS exploit. It took one of our modules that we have is we buy threat intelligence, we take the threat intelligence and we create tests for it autonomously. So in this case, CUPS was, we take the threat intelligence within an hour, one of our modules ran, built a test for it, created a PR for it, and then one of our engineers still needs to accept it, but at that point, it gets deployed to our framework and gets tested on our customers. So in this case specifically, you had to go and find port 631, then run the exploit over UDP, and then find that it would disclose some information. We ran it also, so we ran it first on all our customers. Nobody had a hit, so it was very boring. But then we ran it also on all of Europe, and we found around 6,000 companies that were vulnerable for it. Even vulnerable here is a big word because they were only vulnerable while under very specific circumstances. But yeah, that was that's one of the adoptions that you can get from using AIs in these systems. It's just the speed at which you can create new tests in a completely autonomous way is quite fun and can be good for bug hunting as well. So yeah, these are a bit the company. Yeah. One more question?
It's a bit off topic, sorry.
Yeah.
So you said at the beginning, once you go hacking, you never go back.
Yes, I feel like that.
For me, it's like once you go crypto, you never go back. So you've been running a crypto exchange. When you've been running a crypto exchange, did you feel like a crypto native, or did you feel like you're running a Web2 business and you didn't get the crypto bug?
So I would say it's the other way around. I had very much a crypto bug, especially at the beginning. But at some point, I was not as excited anymore about the financial drive of the crypto platforms, right? It became all a bit of a casino. Whereas back when I started in 2012, it was, hey, this is fun. We can send stuff to each other and there's nobody in between. So it was more the technical piece that interested me most around blockchain and crypto. And after a couple of years of building crypto exchange, by the way, I had a great time building crypto exchange, and I'm very proud of what we did and what the company accomplished. But at some point, I was like, it's a good time to move to something else. Also, I was an ethical hacker before I started crypto exchange, so I just went back to my roots.
So already like in 2019, you realized it's a casino.
So I sold the company in 2018. Too early, way too early. But you know, that's at that point I felt like I was running more of a casino than the type of customers changed. I can pinpoint the moment. It was October 2016 when crypto got a lot of mainstream media attention, and then our platform went from there's only nerds on there that know exactly how to run a wallet and everything always works and they have a lot of fun doing what they do, to it became an audience that wanted to invest in an asset class, which I respect and I think they should, and by the way, they gained a lot from it. But it also meant that the type of platform that you're building changes a lot, right? It became very much focused on user experience and less about discussing innovations in the space.
Thank you so much.
There was one other question I did.
Just about the CUPS vulnerability, at the end you said you ran the exploit.
Yeah.
How and why?
So the how would be, so one of the things is we built scanners. We also built a really fast scanner, which means that one of the scanners that we made it open source, you can look it up, it's called Sanic. We can scan every IP address, every IP4 address specifically in the world in about 20 minutes, as long as your data link cable is big enough. And Europe has not that much IP addresses, so it's much faster than that. The why is mostly because it's fun.
One last one. I feel like in that demo you gave, the safety check model feels like it's putting a lot of weight in terms of making sure that this is a good procedure that follows the guidelines of becoming a web action expert. I was wondering if you could talk a little bit more about that and how you actually build a model, leverage against the main model that's in there.
Shall we? I mean, I would love to talk about it, but I know that I'm a bit. Okay. So, look, actually, of the three models that I identified, there's three, like I said, in an attack chain, you have three larger models, right? Exploit generation, safety check, and impact detection, basically. The safety checks are actually its easiest because it is purely based on the code that was generated. So there's not a lot of context, a lot of other stuff that you need to add to it, which the exploit does need, and the impact is the most complicated thing because you have to assess for a wide varieties of outcomes that can potentially be meaning something, right? Safety check just checks the code. So it's in that sense, it's actually the easiest model to train. The only thing that you're going to do is you're going to basically give it a lot of examples of what not to do, and that's it. You can probably just go in cloud yourself and run do a bad attack. I'm 99.99% sure that it will able to do this without any guidance on top of telling what is right or wrong. It will be able to tell you, well, this is destructive or not. But it's pulling a lot of weight because it's very important. Also because the exploit model tends not to care, right? It just wants to exploit because that's what it's been told to do and trained to do as well.
Yeah. How are you narrowing? I know you mentioned guardrails, so you're using them on all your models. So hallucination is reduced to the minimum. The exploit model could be the worst one, right? Hallucinate.
So yeah, it's also the most guilty one. It does it most often, yeah.
So you have minimum hallucination on that one.
So by the way, hallucination has with the improvement of models, it has gone down very, very significant. You can reduce hallucination mostly just by giving it more accurate context. And just in that context window, you just define the set of truths, and then hallucination should be very limited. What you're seeing in that exploit generation is sometimes because it has general knowledge from being an LLM, and you're told you are a cross-site scripting model, it will still try to do an SQL injection. Right? And that's then something that also your safety model check will have to accurately defend against, because fundamentally it also has some knowledge around SQL injections. It's just not really good at it.
Where are you putting your temperature there then to make sure that you're not going too rigid, or at the same time you're not losing out on creativity because when you're exploit, you don't need to be more creative.
So we give it very little guardrails towards it can create. Because for us, the guardrail is then the safety model, right? So the guardrails that we give for the attack model are primarily on where to attack, right? What data to use, what endpoint to use. So it should not suddenly, when I told it go and try and exploit the search bar, it should not suddenly start building exploits on the same page for different input fields. But as far as the creativity it has, that is fully checked and maintained by the safety model.
I completely get, obviously, the whole automation and finding context, doing everything at scale and very, very quickly. The one bit I'm not clear on, and whether you said it or not, is are your LLMs basically using known attack vectors, or are they actually finding new attack vectors?
So we have currently 12 CVs accredited to our AI models. So sometimes they find something new. We found something about 3 weeks ago, and we got a CVE for it. but it's not public yet. So sometimes you find new stuff. The vast majority, the reason why companies buy us is because we verify that the CVE is not exploitable, right? That's the biggest problem that these large enterprises face is I have hundreds of thousands of vulnerabilities exposed to the internet. Where do I start? Well, you start by just knocking them down by telling that they're not actually exploitable.
Thank you very much.
Thank you.